So when I'm talking about the constant parent function, there are only two things that I have memorized. Okay, I have memorized the function equation. F of x equals c. Okay, the constant parent function is any line y equals or f of x equals c. What kind of line is that? Straight. Yes, they're all straight lines. What kind of straight line? It's a horizontal. If it's y equals any number, it's horizontal, right? So recognize the fact right now that when I graph this, I have to graph my horizontal line at a number. I don't have a choice about that. I have to put it somewhere. But I'm just going to kind of throw it on the graph here and say, all right, I don't care what number that actually is. We're going to call this f of x equals c. So when we answer these questions about it, don't think about it being at 5 like I actually drew it. It can be anywhere. Anywhere that is not the x-axis. Okay? So f of x is equal to c anywhere along a horizontal line, somewhere on that graph. If I look at that, now that's all I have memorized for this. Every single other blank is coming from that graph. So I look at my graph and I say, all right, that graph goes to the left and to the right. What does that make my domain? Negative infinity to infinity. What's the shorthand notation for that? All real numbers. If you don't know that one, that's a R with a double line down the back. You may use that. If I am talking about my range on that, this has a very specific range. It's not a range of values, bottom to top. It is only at one y value. And it's not 5 specifically, even though I've drawn it at 5. What is it? C. So we're going to write our range as just C. You may write it in brackets like that. You may write y equals C. Either of. Okay? Zeros are also known as what? X-intercepts. Where does that line cross the x-axis? It does not. So there are none. This is why I said you can make your horizontal line anything but the x-axis, because that's a very specific horizontal line that crosses the y-axis in every location, and we don't really want to deal with that. Y-intercept, generally speaking, for this is what? C. Good. Now, symmetry you may or may not be familiar with. You have 3 options for symmetry. Even, which is y-axis symmetry, odd, which is origin symmetry, or none. So for symmetry, I'm literally thinking about if I have a piece of paper, which you guys actually do, if I take that paper and I fold that graph on the y-axis. Think about the preschool butterfly paintings. Do you remember those where you did like 1/2 and then you folded it and smashed it? That's y-axis symmetry. Okay, where if I folded the paper down the y-axis, it matches on either side. Is this y-axis symmetry? Yes, it is. So we call this y-axis or even symmetry. No. So your options for symmetry are even, odd, or neither. What really tells me by the quiz, if no one has studied this, is if people say yes or no on that. Not an option. Even, odd, none. Okay? Now, continuity, that is a yes or no question. Continuity is a big fancy word for, is this function continuous? Yes or no? Continuous, all that means is I can draw that without picking up my pencil. It's in one section. So this is a yes. Okay, so if my function can be drawn without picking up my pencil, my answer to that is yes. Now, end behavior is always the one that we're not real sure about how to write, but we're going to talk about this and kind of work on it. End behavior is essentially 2 math sentences, okay? This right here is a sentence about the left part of your graph, and then the second part is a sentence about the right part. So when I am doing this, to fill in that first sentence, I'm looking at the left end of the graph. That's why you call it end behavior. On that left end, what does the arrow mean the x's are headed out to? Negative infinity. So that's my x. X is headed to negative infinity. Now, as that x is headed to negative infinity, what are the y's doing? They're staying the same. They're staying constant at what specific y value? C. Now, if the y's were headed up, we would say they are going to infinity. If the y's were headed down, we would say they're going to negative infinity. Okay, so you have options. Now, the second sentence is about the right side of the graph. The right side of the graph, I'm looking at the right end. On the right end, where are the x's headed out to? Infinity. And as the x's are headed out to infinity, what are the y's doing? Hanging out at C. So, my point of walking through that with you is I memorized the equation and the graph. What did I do to get the rest? I looked at the graph. I'm not asking you to memorize 10 functions like 10 blanks apiece. That is actually the worst case scenario. What I actually want is you to be able to read a graph, because if you can read this graph, you can read the graphs from last night's homework and find domain, range, zeros, symmetry, all of that. It helps you across the board to be able to read these graphs for your parent functions rather than memorize. Okay? So here's what we're going to do. Question?
So on the symmetry part,
Mm-hmm.
you said it was even, odd, and neither.
Even, odd, and neither. Yep.
How would it be odd?
About to see that. Good. So those are your options for symmetry if you want to write them down. Let's take a look at one more. I'm going to get you started, and then we're going to talk through the answers. I will give you the rest of the equations and graphs, and you will work through filling out the blanks with someone near you. Okay? So the second one that we're looking at is the linear. Most of the time we remember the linear one. Anyone remember that? Y equals what?
MX plus B.
Okay, it's like mx plus b. The most simple form is y equals x. That is a line with a slope of 1 and a y-intercept of 0. So that basic line, I don't even need to memorize the graph on this one because I know how to graph a line, right? I know what that looks like. Take a minute on your paper and see what you can fill out. You might not be able to fill out every blank on this, but since we asked, this is a great example of odd symmetry. Think about if you had to fold it over the y-axis. That piece in the first quadrant would then have to be reflected over in the second, and it is not. This is an odd symmetry graph. All right, so the next one is your quadratic. Anyone remember what the equation is for that? F of x equals x squared, and the basic graph of a quadratic is what? A parabola that starts at 0, 0 in the middle. U-shape. So some of these will be super familiar to you already, which is great. Less memorization. Next one on the list is the cubic. Anyone remember the function? F of x equals x cubed. Anyone remember what that graph looks like? It's a little S shape. Yes? Like that? Okay. On the following page is your absolute value. Absolute value is f of x equals the absolute value of x. Anyone remember what that graph looks like? V shape. That's the square root one, I think, or the cube root one. Right underneath absolute value is the cube root, which goes a lot with the cubic. So the cube root is f of x equals the cube root of x. That graph is a sideways cubic. So it's also an S shape, but it's going sideways rather than up and down. This is the cube root function. Okay?
Wait, does that have to be is that the top part, is that where -3 is going straight and long enough to,
It doesn't go horizontal. No.
What?
It keeps increasing.
Yeah.
Yeah?
No.
You're just drawing a sketch. That's all. On the following page, we have rational odd, rational even. Yep, we're getting more. All right, so the rational odd, rational even, these are our first discontinuous graphs. Rational odd is like what we saw on our homework last night with the asymptotes and stuff. Your rational odd has the two branches. Also, rational odd, rational even give away their symmetries in the name. So please don't miss those. Rational odd has odd symmetry. Rational even has even symmetry. You will also notice that the symmetry does frequently have something to do with the exponent involved. For example, if I had to take a guess at a quadratic, I would say that was even, because I can see the graph, but also because the exponent is 2, an even number. Cubic, odd. It's 3, odd number. Okay? So a lot of these will have something to do with the exponent. Rational odd is y equals, or f of x equals 1 over x. Rational even is 1 over x squared. This one is what we sometimes call the volcano graph. Looks like this. Okay. It also does help you on like a test or a quiz to remember odd should have odd symmetry. So it reminds me that the branches are diagonal from each other, where the even one is across the y-axis from each other. Okay? Last two. The square root function, f of x equals square root of x. You've been waiting for this one? This is the one that starts at 0, 0 and goes to the right.
Oh, yeah.
And then the last one does not have a name. It's a function that is good to know about for calculus purposes that is used frequently. It's the absolute value of x over x. The good news with that one is I can't actually make you memorize the equation because I can't give you a name for it and say, what's the equation, right? I have to tell you y equals absolute value of x over x. So that funky no-name one is that equation there. And this one is very specifically at 1 and negative 1. Open dot and to the right. Open dot and to the left. Okay. It is actually at 1 and negative 1. It's not like a C. All right, so here is our job for about the next 10 minutes. By yourself or with someone near you. Okay? Go ahead and fill out the blanks on the rest. Yes. So basic transformations. Question 1 says, take that absolute value, move it left 4, and start your absolute value there. Yes? Okay, someone else was too. Hold. Okay. So once we understand the left and right stuff, which you guys did to begin with, so I'm going fast on the left, right, so we have time to do the other fun. Okay? So on 114, we are now adding to what we had. So I had for you, I'm not going to flip back to 114, I'm just going to write it here. I had on 114 the basic absolute value, which we understand could be any parent function. We said that was the right and left and the up and down. There are things that we can add. The first thing we are going to add is an a value out front. Anyone remember what that did to the graph? You did these last year. Okay, it's like a slope. We also call it a vertical stretch or shrink. Okay? If A is larger than 1, it's a stretch. Okay, so if it's 2, 3, 4, the fraction 5 over 2, any number larger than 1, it is a stretch. If A is between 0 and 1, such as 1/2, 2/3, 3/4, anything like that, then it is a shrink because it makes it smaller. Okay? Is this somewhat familiar to us? Yes? If it's a negative, that is a completely different transformation, which I was actually just about to add in. So, if I added a negative out front, that negative is a second transformation, okay, and it is a reflection over the x-axis. So what I'm going for on page 114 is eventually by the end of this to have one big equation with all the transformations written down for you. Okay, but we're building. We're building. Okay? All right, so given what we just said about those being vertical stretches and shrinks and reflections, let's go back to page 117. I'm going back. there's one more thing that we can add in. Okay? A negative on the inside is a reflection over the y-axis. Yes, ma'am. We're going to talk about that last. Yes. All right, so we're going to start with an easy one. Question number 4. Question number 4. It does not have any left or right business. It just has that number out front, which we said is called a vertical what? Stretch. Here's what this does. I know my absolute value usually starts in the middle at 0. A vertical stretch means that it stretches upwards. Okay, it affects the y values. So normally, my absolute value goes up 1 over 1 on both sides. What does that 3 make my absolute value do? Up 3 over 1 on both sides. Okay. Now, we started with an easy vertical stretch shrink. 5 is not super difficult, but it does have 3 transformations in that. What's one transformation that you see in question 5? Up 4. We always say that one first. Yeah? And I say 3 because this negative and this 1/2 are 2 separate transformations. And if I ask you to name them, you will have to name both. Okay? That 4 is, like we said, an up 4. What did we say about the number out front? What does the 1/2 do? It's a vertical shrink. Okay, and what did we say that negative is? Reflection over the x-axis. Now, here's where it starts to be that some of us are better at doing these like all in one step than others. Some of you are going to look at me like I'm crazy when I do this in like 3 steps. But I do it for the people that are like, I'm sorry, what are you talking about? Okay? If I do this all at once and I say that means up 4, negative slope of 1/2, blah, 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 some people are going to be like, I have no idea where you got this. All right? So just understand that. Others of you are 5 steps ahead of us. That's fine. People are visual or not. So I would start with, there's my basic absolute value. I'm not going to draw all of that because I don't feel like erasing all of the lines. So there's my points. You must start with doing anything that is considered a multiplication or division first. This is where we often don't remember this from Algebra 2. There is an order of operations to transformations. If you go up 4 first, you will frequently get it wrong. Frequently, not always, because sometimes it's okay. Sometimes it's not. It just depends. So always do multiplication and division first, then addition and subtraction, which means I'm taking care of the negative and the 1/2 first. Do you want to do the negative or the 1/2? I don't care. Both? All of it? Okay, let's do the negative first. The negative is a reflection over the x-axis. This means it takes those points that were up 1 and flips them over the x-axis. What's it do to the middle point? It stays there because it was already on the x-axis, right? So it took that entire thing, flipped it over the x-axis. Now, what is a vertical shrink going to look like on this? Wider. It can look wider. That's more of a horizontal one, which we'll get to in a minute. But what it means is my slope was 1. I now erase my points and I make my slope 1/2. So it cuts the vertical distance to those points in half.
Does that mean the second point is 1?
Yes. Now, I'm sticking with just the first point on either side, and that's why I'm making it 1/2 rather than going out 1 over 2, because that works for absolute value. Doesn't work for every other one. So I'm sticking with the first point. Are we all okay with the negative and the 1/2? Now I take all 3 of those points and move them which way? Up 4. Okay, so when I move those points up 4, I get to here. Now, could you have been fine if you did the up 4 first and then flipped it? If you actually did it right, no in this case. Because if you moved it up 4 and then flipped it, it would have ended up down 4 on the bottom. See how the order matters? That's not okay. So you got to do the multiplication and division first, then the addition and subtraction. Okay? Make sure you do it in the right order. All right. Let's take a look at I want to do more of these. Scratch out question 6. Scratch out question 6 and let's write something in its place. We are going to do 2. All right. Now, I've changed a couple things on this one. I'm making up my own examples because they don't have any more stretches and shrinks. I changed my notes this year and I hate them. So, making my own as we go. Here we go. All right, let us talk first. In my new equation, what is the parent function? It's a cubic. So let's briefly remember parent function cubic. What does that look like? It's the S shape. And in fact, it has 3 points that look like they should be in a line, but looks like that. Okay? Again, I'm not going to draw the actual S shape. Now that you've seen it, I'm going to erase it. I'm going to stick with my points. First transformations. What do we see? Just naming. Naming transformations. What do we see? Okay, I've got a down 1. I've got a left 3. I've got what else? Reflection over the X and vertical stretch of 2. Which ones do I have to take care of first? Anything that's multiplication and division first. Okay, so the first thing I'm going to do is take care of the negative. Reflection over the x-axis means that this point flips down here, and this point flips up here. Yes? Okay. So, and some of you will start doing the stretch with it and saying the negative does the flip. The stretch means that instead of going up 1, it means it goes up 2 or down 2. So it takes this point and stretches it 1 block further or twice as far. It takes this one and stretches it twice as far up. So that means the negative taken care of. Now I have these points. That's what the vertical stretch does. It stretches it either side, up or down. Now, what are my transformations that are left? Left 3 and down 1. So left 3, down 1, left 3, down 1, left 3, down 1. Looks like this. Now, how are we doing with this? Some good, some great. Okay. I am going to throw something out. Is there anyone right now that is like, holy cow, I am not a graph person and I don't like doing this on the graph? Are we all okay?
But I have a question about it.
Yeah.
You said it's important to do it in that order. Left 3, down 1, and then just in the stretches. Give me consent, right?
It does not turn out the same way every time. There are occasions that it will.
Like down.
Let's see.
I just go left and down 1, and then I just...
If I took my 3 originals, let me just see. I know there are some. So if I take this, yeah, it does sometimes. I don't know if it did on this one. Left 3, down 1 would land my points here. Okay, then reflect. It would flip the 2 bottom points up here. And then stretch means this one would double up to 4. This one would double up to 2, and that one would stay. So if I did it in the wrong order, I'd end up with that.
Oh, how did your graph do like this? How did you go up?
Because when I reflect it, those green points flip up here.
Oh.
So if you got the right one, it just means you did it incorrectly and managed to do that on that. Okay? Okay, so are we all pretty comfortable with those graphs at this point? Yes? Okay. It would be beating a dead horse at this point to do more examples. You really just have to do some yourself, honestly. Okay, so I need to talk about homework real quick because it is a little bit complicated today as far as what you were supposed to do. Okay? If you would, flip with me to page 122. All right. Page 122. 122 looks like, and there's lots of extra practice should you need it. I'm not doing all of these. So 122 is this, okay? Homework is two different parts. I have a page that I'm going to give to you that is extra graphs because I don't like section 2 on page 123. So here's what our homework is. 122, 123, and 124, but on 122, I would like you to cross off this graphing section, 1 through 6 right there, okay? Because I have a page of graphing. Just cross off section 2 on 123, okay? All right, now, again, I know this is going to look like a lot to us, okay? I get that. But what first and second period saw was that everything in the notebook took about 15 minutes in the rest of class, and then they had this page for actual homework. Okay, so it's not really that much. Because, like on this page, there are no vertical stretches and shrinks. You're simply looking at this graph and saying, this is an absolute value that's moved up 3. Y equals absolute value of x plus 3. Done. Okay? So a lot of these you should be rolling very, very, very quickly through. On section 3, on page 123, all you are supposed to do is name the parent function and say the transformations. So the first question there, square root, left 4, down 5. Done. Okay, don't take too long on these. On section 4, you are writing the equation. They are telling you this is a quadratic. So that's an x squared function, moved up 3 and left 7. Okay? Couple notes on language on this one. If it says reflex, assume that's in the x-axis. And for some reason they say vertical instead of stretch. But there's that. Okay? Now, I told you there was one additional page of graphic stuff that I have for you, okay? And I want to talk about the last piece of the transformations to do that. I know today is kind of a lot, but, okay? In order to do this, the last thing we have to talk about is a horizontal stretch and shrink, which we did not, so head back to page 114 real quick. I know. Head back to page 114 real quick. There's a method to the madness, I promise. Yep. Alright. Alright. On page 114, we have one additional thing to add to our big ol' equation. Okay, so if you want to add it in, you can, or you can pick up and write a new equation on page 114. But last part of this, and then I am done. So we built a big equation on page 114. So far, we have A with a negative. We said A was your vertical stretch or shrink, right? The negative was your reflection over the x-axis. Inside, we said we had an x minus h, and that h was your left, right. And then we had a plus k at the end, and that was your up, down. There is one more thing I can throw in here. There is something that we put in here that is called a horizontal stretch or shrink. Okay? These are not overly common. But there's a trick to them. And there could be a negative. Any guesses what that reflection is? Okay. And this is literally all the transformations you can have. So we built all of that into one big equation, understanding I'm using absolute value for the sake of saying here is a parent function that I'm doing this to. All right? Now, here's the thing about the horizontal stretches and shrinks. The trickiest part of these. Remember how in the parentheses with the x, if it says plus, we actually go left. And if it says minus, we actually go right. It's the opposite. Someone said that at the beginning, yes? The horizontal stretch and shrink is the exact same thing. It's the opposite, okay? So what this means, let me just show you a basic example. If inside I multiply by 2, that's not actually a horizontal stretch. What is the opposite of multiplying by 2? Dividing by 2. This is actually what we would call a horizontal shrink in half. This looks like it's multiplying by a half. The opposite is what it's actually doing to the graph. So if it's a 1/2 inside, it's actually a horizontal stretch. All right. What helps me keep sane on those things is that everything on the inside is the opposite. Always. If it says plus h, you're actually minusing h. If it says minus h, you're actually plus h. So that means, everyone grab that extra sheet that I gave you. Take a look at question 2. 2 has that in there. You didn't get one? 2 has the 2 on the inside. So what would I call that 2? A horizontal what? Shrink. It actually cuts it in half horizontally. Okay? For the sake of our argument, let's all take this page that I handed out and let's do 2 together. Okay, and for those online, this is available to print on my PCA on this assignment. But I'm going to do question 2 all together. All right? This is the last question I'm going through. I am done. Question 2 on this page, and this gets one of your homework questions done. Oops, that's not a -2 in there. That's just a 2. Well, okay, so if you don't want to draw the graphs, I'll tell you this in advance before you leave. You may grab a page of this and just like write the equations on the top of each graph and use the graph paper. Okay? I'll have it here, or if anyone wants them, I'll pass it out. Okay. Anyone want a page? Anyone want a page?
Thank you.
Okay, if you do, raise your hand. I'll come around and graph paper for you. All right. Everyone. All right, you can draw your own graph if you want. You don't have to. You're welcome to just write this at the top. If you are online, if you just Google graph paper, you will find pages of graphs. You're welcome to use that to write the problems down. All right, so we're all going to do question 2 together. First, what I would like for you to do is somewhere write down the transformations that you see there. Okay, there are 1, 2, 3, 4 of them.
On the paper? Wait, oh.
Somewhere. Yep, that's the problem we're doing. This is question 2 on your homework sheet. We're going to transfer this onto graph sheets. Okay? You can write it real small on your graph sheet. You can write it on the assignment page. I don't care where you write it. All right. I'm going to start with the obvious ones. You can do that if you want to, or you can just list them. I don't know why I'm saying down. Up one. All right, so those are the ones that I have written down. The first battle in transformations is just being able to identify what the heck is going on. Okay, writing them down. Big thing. Second thing is graphing. All right, so this is our last one. Absolute value is our parent function, yes? So absolute value starts at 0, 0, and has a point on either side. What transformation should I start with? The reflection. What does the reflection do? It takes these 2 points, flips them over the x-axis. So I start there. Now, second thing that I have to do is what? Horizontal shrink. Now, this is horizontal, so we're thinking x distance. The x's are out 1 to the side. What does a shrink do? Moves them in half the distance. The y does not change. The x does. So that means I'm going to erase those points, and I'm going to take them in half of a block. That looks like this-ish.
So it looks like it's
Yes, horizontal stretches or horizontal shrinks and vertical stretches can look similar. Yes. So they can look like one or the other. The last thing I will do is take all three of those points and move them which way? Right 2, up 1. So that is going to be, I'll go in a different color here. Right 2, up 1, right here, here, and here. So a horizontal shrink can look a lot like a vertical stretch. We just took those 2 points and we shifted them in half the value. Okay? All right. I am going to be done at this point because at some point you just need to start doing some of them. I will say that I had a couple people from yesterday that were like, I'm a little lost. One-on-one can really help this if you will come in for tutoring. Okay? The quiz over this is not till next week to give you a shot at coming in if you have to. Okay? If you have questions, please let me know. Online friends, you don't have to stay on it if you do not want to. You got about 5 minutes left. I'm done.
If you need help, you can just. Yeah.
Switching here. If you are done, go ahead and leave your seats out because I'll start spraying for the next class so they have a chance to dry. Sticking with me, I know that was kind of a long lesson. You feel okay? Oh, that's good. But I will tell you, y'all are walking out to the morning. I'm doing good. I want to. You are good. It's wonderful. I am. Good.